Hey everyone, my name is Anthony and I'm a program manager on Azure Functions. And today we're going to write some Azure functions in Go. Let's get started. All right, so before we get too far, we should talk a bit about how Azure Functions works. Depending on the language that you're using, things are going to work a little bit differently. If you're using something like JavaScript or Python, you'll just be writing and deploying some code, functions if you will. And whenever an event that you care about happens, like an HTTP request or a timer firing or a message appearing in a queue, your function will just get triggered and the code that you have in it will run. And it's really that simple. So for languages like C# and Java, you'll be taking an extra step of compiling your function into a DLL or a jar file first. And then when an event fires, your function is triggered, just like the other languages. For languages like Go and Rust, you'll be building something called a custom handler. A custom handler is basically a process that will be triggered when events occur. And the process is managed by the Azure Functions platform. So you don't really have to worry about starting it or managing it. That's all going to be done for you. And the handler is going to be invoked over HTTP. So what that means is that you'll basically be building a web server, and any language that can respond to HTTP requests can be a custom handler. So these things are really quite simple to build. And keep in mind that even though the handler itself is going to be called over HTTP, it's going to work with other triggers and bindings that Azure Functions supports as well. So we'll be able to build more than just HTTP triggers with this. And another thing I want to point out is that each instance of your custom handler can handle more than one request at a time. And when you deploy it to the cloud, we'll actually scale it to more and more instances for you as you get more and more events. Okay, so let's get started building our first custom handler in Azure Functions using Go. So I think the simplest way to get started is actually to take an existing Go application that implements an HTTP REST API and then turn that into a custom handler. So you can see that I have one on the screen here. It responds to HTTP requests at /API/hello. And whenever it receives an HTTP request, it's just going to execute this function here, which basically just says hello back to you. So we're going to go ahead and build this application. And then we're going to run it. And then we're going to click on the link. And then we'll type in /API/hello. And then we get our response. And of course, we can also add a name as the query string for it to say hello back to us. So pretty simple. So this just shows that our app works before we start turning this into a custom handler. Okay, so let's go ahead and turn this into a custom handler now. The first thing that we want to do is we want to make sure that our VS Code has the Azure Functions extension installed. You can see that I have it on the left side there. So the next thing that we can do is that in our command palette, we can choose the create new project command from that Azure Functions extension. And then it's going to go and ask us where we want to create the project. We'll just choose the current directory. We'll select custom handler as the language. And then we want to build an HTTP trigger, so we'll select that as well. We'll name it hello. And then we'll just take anonymous auth. And then that's it. It's going to go ahead and scaffold out our custom handler project for us. So the first thing that it puts up on the screen is the function.json. And the function.json describes the Azure Functions, what the triggers as well as input and output bindings are in a function. So our function has an HTTP trigger, and it also will return some result to that HTTP trigger as well as an output. And then the next file that we want to look at is a file called host.json. And host.json configures the Azure Functions host. In this case, we want it we want to tell Azure Functions to start our server process. That's our custom handler whenever the host starts. So you can see down below, we already have a custom handler section scaffolded for us. So we just have to put in the name of our executable, and that's about it. We don't have to worry too much about the working directory or any arguments. Our executable is really easy to start. One thing that we do want to make sure that we set is this setting called enable forwarding HTTP request. We'll talk a little bit more about this later, but this just tells the host to take any HTTP requests that we get and forward it directly to us without any modification, so that the handler will get a copy of the original HTTP request that was received by the function app. And then it's also able to respond with an HTTP response that will be relayed back to the calling client. Okay, so there's one more step before our app becomes a proper custom handler. And if we look at our code, you can see that we're listening to port 8080. And when the Azure Functions host starts our process, it's going to pass an environment variable to us called functions custom handler port, and we're expected to listen to that. So we just added a couple lines of code to do this. And now our app should work properly as a custom handler. Don't forget to build it again. And now let's start the Azure Functions host. And what we're going to see is that our process is going to be started up as well, our handler process. And it's going to be listening to a random port that the Azure Functions host has selected. And that's the port that the host is going to use to communicate with our custom handler. And if we click on the link that's printed to the terminal, it'll open up a browser and call our function. You can see that it's working, and we can also pass in a name. So it's working just the way that it was before, but now it's working as a custom handler. Okay, so that was an HTTP trigger. So what if we want to do other things like respond to a queue message appearing on a queue? So let's do that right now by creating a queue trigger. So to do this, we can open up our command palette again and select create function. And then we can choose the Azure Storage Queue trigger. And then we have to give this thing a name. So we're just going to call it queue trigger. And we also have to select a variable name that we're going to store the connection string in. We'll do that later. And we're going to give it a name. We'll call it items. So that scaffolds out a function.json that describes this new second function that we've added to our function app. It has a name of my queue item that'll come in handy later, so remember that. And you can see also our queue name is there of items. So now let's go to our server.go file, and then we will add an endpoint in here that will be triggered, or that will be called whenever that queue trigger runs. So we're just going to create a new route. And by default, Azure Functions is going to invoke our handler at the root using the name of our trigger. So in this case, it's called queue trigger. It's actually the name of the function. And now I'm just going to paste in some code, and then we'll walk through it. So the first thing that I want to do is just import JSON. And you can see that this is just a pretty typical HTTP endpoint. It's we're taking in an HTTP request, but because this request is not a normal HTTP request, it's going to come in this special format that's going to contain information about our queue message. So we're going to have to decode that first, and then now that it's decoded, we can access the queue message itself. So if we remember a couple seconds ago, we named our queue trigger my queue item. So it's going to be accessible inside of this dictionary as my queue item. And if we wanted to do anything, we can just put some code there. But in our case, we're just logging some stuff out. And to log things, we just have to create this response object. That's also another kind of special payload that we're going to return back to the function host. And we'll just append a couple of log items in there. So if we can take a look at this response that we're sending back to the function's host, you can see that it has an output. So any kind of output bindings that you want to send messages to, it'll be there, as well as logs. All right, so let's go ahead and build our custom handler again. All right, so we actually forgot one thing, which is to configure our function app to listen to a queue. So let's do that now. So when running locally, we can actually use a storage emulator that emulates queues locally on our machine, so we don't have to actually connect to anything in the cloud. So in Visual Studio Code, we could install the storage extension as well as the Azure extension. And then we can start the emulator from within our extension. And then once that's done, we can create a queue named items. And then we can right click on the local emulator and copy the connection string. And then we'll paste that into the variable that we specified earlier when we created the queue trigger. And this local.settings.json file is only used when you run locally. And when you deploy it in the cloud, we're going to set the connection string somewhere else as an app setting. So we've started up our app, and now you can see that we have this extra trigger here now, our queue trigger. Now the app is started, let's use another tool called Azure Storage Explorer that's going to help us add some messages to the queue. So you can see that I have the same queue open in my Storage Explorer, and then click on Add Message and provide in message. And when I click OK, you can see that pretty much instantly the Azure function triggers and calls our custom handler that prints out that message that was passed to the queue. Let's do it again, just to make sure it's working. Click OK. You can see pretty much instantly our message is printed. So it's super easy to build a queue trigger using custom handlers. All right, so let's try deploying this app to Azure now. So because I'm working with Go, so we're working with compiled binaries here, and currently I'm on a Mac. So my binary is compiled for Mac. And if I want to deploy it to the cloud, in Azure, Azure Functions can run with Windows or Linux. So in our case, let's try deploying it to Windows. And what that means is that we need to recompile our app to target Windows. So we'll cross-compile our app to Windows. And we'll see that we now have a new file called server.exe. And if you remember from earlier, in our host.json, we're actually specifying the name of the binary or the process to start. And because in the cloud we want to use server.exe, we need to make that change here. So now the application knows how to start a handler when it's running in the cloud on Windows. So now it's time to deploy our application. So we'll do that using the command palette. And then we'll select our subscription. And then we're going to say, create a new app in Azure. We have to choose a globally unique name for our application. And then the runtime stack is custom handler. And we're going to choose Windows. And the consumption plan. And then it's going to ask us for a resource group. We'll just take the default name. It's also going to ask us for a storage account. That's where we're going to store the code. And that's also where our queue is going to live. And we'll also select a name for our application insights resource. That's going to help us monitor our app. And then we're going to choose a region. So it's going to take a couple of minutes for our app to be created in Azure and deployed for the first time. And we're going to use the magic of television to fast forward through all this. And once it's done, we can click on View Output. And then in the output, we can see the URL of our HTTP trigger. We just simply click on that. And you can see that our function is now running in the cloud. We'll enter our name to see it say hello back to us. And now our app is deployed. And if we want to test out our queue trigger in the cloud, we can use Application Insights for this. So this is the Application Insights resource that is tied to our Azure Function app. And if we click on Live Metrics, this is going to give us a real-time view into what the function app is doing, including any logs that it might be outputting. And then we can switch over to our Storage Explorer. And instead of connecting to our local storage account, we'll connect to the one in the cloud that's tied to our function app. And then we're going to create a queue called items. And then we'll add a message to it, just like we did before. And when we click OK, there's a slight few second delay before that might appear in this, this real-time view on the right side there. And now we're going to dig through all the log messages to find this one that was printed out by our custom handler. And this is the queue message, or the contents of the queue message that it printed out. So we can see that our queue trigger is also working in the cloud. So now that we have our app working and deployed, let's take a look at some tips and tricks that's going to help us as we continue to build out our custom handler app. So one of the things that you probably notice is that we now have two copies of the binary for our handler, one for running locally and one for running in the cloud. And we have to keep switching this default executable path in our host.json back and forth as we're deploying or running it locally on our machine. And we can avoid doing this by using local.settings.json to override that default executable path that's in host.json. So in this case, I am using this variable here to override it to the value of server. And then note the segments in this really long setting here. But this is how we can actually override any setting that we have in host.json. So you can see that the identical kind of path that's in host.json matches what we put in to local.settings.json. So now when we run our function app, even though host.json still points to server.exe, it's working. And that's because the local.settings.json file is overriding this for us right now. Sometimes you might have lots and lots of routes in your custom handler that you want to send HTTP requests to. And you might not want to create a function definition for each one of them. So let's take a look at how we can create a single function that can route all requests to our custom handler. So what I'm doing here is that I'm just quickly adding another endpoint to my custom handler app. And this particular endpoint will respond to pretty much anything under /API. So you can go /API/foo or /API/bar, and they will all call this all handler function here. Let's quickly build our custom handler. And then we'll start our function app. And because we haven't made any changes to the function app itself, it's still only going to listen to this single endpoint. So let's take a look at how we can change this endpoint into what we call a catch-all route. So the first thing that I'm going to do is change the name of the function. This is kind of optional, but because it's no longer the hello function anymore, it's going to capture all requests. I'm just going to rename it to all. And then inside the folder in function.json, we're going to add an extra property called route. And we're going to put in a special value in here with a couple of curly braces, a star, and then just any kind of a name. So I'm just calling it path. So now the route is going to match anything that in this case, by default, is going to be under /API. So I'm going to go and build the app again. I actually probably don't even have to do this. I didn't modify the app. And then I'm going to start the functions runtime again. And now you can see that my route is a little bit different. And when I go to the browser and I go to /API/hello, it still goes to my hello handler. But now when I go and change it to some other value, say for instance /API/testing, you can see that it's actually hitting this other endpoint that I created. So now I have this one single function that will forward all requests under /API to my custom handler app. So that makes it really easy to convert any REST APIs or HTTP APIs that you might have into a custom handler app. And the last thing that I want to show you is how to debug a custom handler app. And because a custom handler is just an HTTP server, we can enable some extra logging in the Azure Functions host to see how the functions host is calling the custom handler, as well as the responses that the custom handler is returning. To do this, we need to go back into our host.json, and then we need to add a log level, a default log level to the logging section, and we'll set it to trace. And then we'll go ahead and start our function app again. And what we're going to see now is a lot more logs being printed to the console. And we can test this out by sending a message to the queue that our function app is listening to. And then we can see that the function has been invoked and more logs are printed to the screen. We can stop our app now and just kind of scroll through all the trace logging that were output and find the pieces of information that we're interested in. So it looks like it's right here. Let's expand this window a little bit so we can see more. You can see exactly how the function is being invoked. The functions host is making a post to /queueTrigger on our custom handler in this case. And then down below, you can see the payload that was sent to our custom handler. So I'm going to copy this piece of JSON and then open a new text editor. And then we'll switch over to JSON formatting and format it nicely so that we can take a look at what's inside. And we can see that in the data section, we're being passed the body of the queue message, but we're also getting some metadata about this queue message as well. And back in the logs, we can also see what the custom handler itself has returned back to the Azure Functions host. And that's all I really wanted to show you about how you can build, deploy, and also debug a custom handler app in Go in Azure Functions. All right, so that was my first video. If you liked it, let me know, and maybe I'll do some more. Thanks so much for watching.